Okay, so we're going to look at intramolecular forces versus intermolecular forces. I'm going to keep it simple. Make sure you take notes and then take those notes and use those notes on the quizzes that follows, okay? And hopefully that'll help you to clarify some of the information for yourself. Let me share my screen, versus intramolecular forces. Inter or intra? I'll write it down. Okay. Okay, so make sure you go down the way. Make sure you have it clear. We've got intramolecular, okay, versus intermolecular. All right, so let's just make sure we understand this difference. These are actually chemical bonds, right? So these are your ionic, your covalent, and one we have not discussed much is metallic, which is just between metals, okay? Those are your chemical bonds. They are intra, they are within molecules. They hold a molecule together. So if we look at our H2O, right? This right here is a covalent bond. And this is an intramolecular force or bond, okay? So your bonds are intra, they are within molecules, right? So when we go C, O, H, C, right? All of these lines are intra. They are holding this discrete molecule together, okay? Just like these lines are holding the water together. Now, when we talk about intermolecular, they are not within, okay? These are not bonds, but forces of attraction. These are weaker than bonds, weaker than chemical bonds. And remember, I think I said very quickly that within our intra, our bonds over here, ionic is the strongest, and then metallic, and then covalent, okay? And that would relate to properties of the bond itself. Strongest bond, weakest bond. Okay, that's cool. If it's an intermolecular, it's not a bond, but a force, okay? We commonly refer to these as IMFs, right? Those are your intermolecular forces. That's what that stands for. Okay, so we'll call them IMFs. They're weaker than chemical bonds. They are not within a molecule. They are among molecules. But between molecules, okay? So it's what holds a solid particle to another solid particle, or a liquid particle to a liquid particle. There would be none in gases because the particles are far apart, okay? So IMFs are stronger in a solid than in a liquid, than in a gas, okay? Because it's what keeps the particles together. Oops, that's not what I wanted to do there. Okay, Now, let's look more at this. So inter is within, all right? What do I mean by inter and being within? Got to visualize this. I'd say that I've got one molecule of water here. Let's draw it kind of like this, right? And I have another molecule of water here. Okay. And I have another molecule of water here. Okay. So right here, notice I've got several molecules of water. Whereas in my other side over here, I just drew one of each. Because over here, we're talking about the bonds that are within the molecule. Okay. And if you're not aware, these would be hydrogens out here. I probably should have drawn those. And over here, I'm not talking about the bonds within the molecule, okay? I'm talking about an attraction that will hold one molecule to another molecule, right? Such that this molecule here is attracted to this molecule here. And this molecule here is attracted to this molecule here, okay? These are my attractions. They're not bonds. They are forces of attraction. Okay, they're not bonds. And when we break them, we do not have chemical changes. We have physical changes, phase changes. It's either pulling these molecules apart or pushing them together, making forces of attraction or overcoming forces of attraction. Okay, so this is a force of attraction, not a bond. Okay, all right. So what you need to realize, very, very important, is the inter, and that's what we're going to be focusing on now, is it's not within molecules. It is between molecules, right? Not within, but between. So it's what holds one molecule to another molecule. Intra is within the molecule itself, right? It is in the molecule. So it holds the molecule together. Over here, we are holding one molecule to another molecule, okay? All right. So now what you have to do is try to learn to understand the different types of intermolecular forces, okay? So we're going to write types of intermolecular forces, IMFs, right? Well, we've got London dispersion. Yeah. London dispersion forces. We've got dipole forces. And we've got hydrogen bonding, which is not a bond. It is a force. They thought it was a bond, so they named it a hydrogen bond. Come to find out, it's not quite as strong as an actual chemical bond. This is the strongest of the three forces, and this is the weakest, typically, of the three forces. Hydrogen bonding is a special type of dipole-dipole. Okay, now, you're not going to get this unless you listen and think, okay? Now, let's look at a dispersion force. No. These dispersion forces exist among all molecules I'm not going to go too much into this. All molecules, and they are the only force between nonpolar molecules. Okay? Dipole-dipole forces is the force between polar molecules. Okay? And hydrogen bonding occurs when hydrogen is bonded to N, O, or F. That would be nitrogen, oxygen, or fluorine. Now, I would love to teach you the chemistry as why and help you to understand what this all has to do with, because it's actually very important. For example, in an AP chemistry class, this is a huge part. Understanding this is very important. If anyone would like me to go in deeper detail, you could let me know. Or just take AP Chem. Just take AP Chemistry. Anyway, I'm going to go ahead and stop, but you should start wondering if maybe you're interested in taking AP Chemistry and understanding this on a much deeper scale. Okay, I'm going to stop. Hope you have a good day.